So today we'll go for dynamic routing protocol. Okay, dynamic routing protocol. Okay, let me show you a one minute. Okay, so routing can be configured either static routing and dynamic routing. Okay, so static routing is manually configured. While dynamic routing, we are using some protocols. Protocol will decide how to configure or how to create route. Okay, protocol will decide. It cannot decide. And also decide if they have multiple route and they installed base route in their routing table. Suppose this is the source, this one is the destination. Okay, from source to destination, I have multiple route. Okay, so
Yeah.
dynamic routing protocol will create all the routes, but on the routing table, only the base route. Only the base route. Base route will be installed. Okay. So dynamic routing has two platforms. Create the routes and select the base route. They always send the packet to the base route only. Okay. If they have, suppose these are link cost 1, these are link cost 2, these are link cost 3. This is the lowest cost link. So this guy will communicate with this guy through this route. And only this route will be found in routing table. Okay. So dynamic routing can be two types. Interior gateway protocol, which we call the IGP, and exterior gateway protocol, which we called EGP. Exterior gateway protocol. Interior gateway protocol is used inside the organization. Okay. And exterior gateway is used to connect multiple organizations. For example, this is an ISP, this is another ISP or service provider. So to connect to ISP, we will normally use EGP, not IGP. IGP used inside an ISP or organization. Okay. So interior gateway protocol again can be distance vector or link state. There are two types. Okay. Distance vector and link state. Distance vector can be IGRP. Example of IGRP, RIP version 1, RIP version 2, EIGRP. Link state, there is only two link state routing protocol. One is OSPF, another one is ISIS. Okay. And BGP, there is only EGP, there is only one EGP, which is BGP version 4. Only one EGP. BGP can be eBGP, external BGP, and iBGP, internal BGP. External and internal. EIGRP also called Advanced Distance Vector Routing Protocol because it has some character which is similar to link state. That's why EIGRP we can also call it Advanced Distance Vector and also or hybrid routing protocol. Because it has some characteristics which can be found from linked state. That's why EIGRP we can also call hybrid routing protocol or advanced distance vector routing protocol. Okay, so these are the categories of dynamic routing protocol. So in NRC, we will study about EIGRP, OSPF, or BGP. ISIS is reserved for CCNP service provider. CCNP service provider only. Okay, so we will continue for EIGRP, OSPF, and BGP. Okay, I will send this. Okay. Now let's go on more theoretical, more concepts. So EIGRP, Enhanced Interior Gateway Routing Protocol. Enhanced Interior Gateway Routing Protocol is called EIGRP, right? This is the shortest form. This one is the full form. It is a dynamic routing protocol which is used to find the best path between any two layer 3 device to deliver the packet. To find the best path. Okay, as I already showed simple diagram. If we have multiple paths from source to destination, so EIGRP will find only the best path to its routing table. Okay, only the best. For example, this one is the best path. Okay, this route will go to the routing table. EIGRP works on network layer protocol of OSI model and use the protocol number 88. Okay, it is not UDP, not TCP. It is the IP protocol number. So EIGRP used IP protocol number 88. It works on network layer. EIGRP works on network layer. Okay, and uses the protocol number 88. IP protocol number, not TCP, not UDP. Uses metric to find the best path. Okay, I will discuss what is metric. I will discuss, no problem. Metric is a composite value. That means to find the best path, EIGRP uses the metric. And to find the metric, they rely on multiple attributes: bandwidth, delay, load, reliability, and MTU. Okay, I will show you. In a well-designed network, EIGRP scales well and provides extremely quick convergence time with minimal network traffic. Okay, EIGRP scales well, more scalable. Why we use EIGRP? Keeps backup routes, flexibility in summarization, unequal cost load balancing. Okay, I will discuss the 3 points later. Just please be remember, EIGRP keeps backup routes, flexibility in summarization, unequal cost load balancing. Okay, I will discuss. So EIGRP is a distance vector routing protocol. Distance vector routing protocol. How? For example, there are 3 routers, R1, R2, R3. Okay, and also here is another network. Here is another network. Okay, so this guy wants to communicate with this one. As it is distance vector, that means to send the packet for a particular destination, to send the packet for the particular destination, it will exit out the packet on that interface and go to the next hop router only. This is the next hop router. So according to the routing table, it will send the packet only to only to the next hop, pointing to the particular destination. Okay, and also they will measure the distance from source to destination. What is the distance between source and destination? For example, they will use the feasible distance value. I will discuss what is feasible distance later. Okay, so distance vector means in a particular destination, and they can also measure the distance between source and destination using the feasible distance value. That's why it is called the distance vector. And also it will send the packet according to the routing table. Okay, it just send the packet to the next hop on and exit out with its interface. These routers have no knowledge about this link or network, and also this router, no knowledge. It only knows the R2 only. Okay, it has the limited knowledge. Every EIGRP router has the limited knowledge. They have no knowledge about the full topology or other routers. Okay, this one is third. First one is in a particular destination, right? They will send packet in a particular destination. That's why it is called vector. And distance means vector distance, total distance from source to destination. Source to destination, total distance. They will find the distance using the feasible distance value. Okay. Also, according to the routing table, they always send the packet, right? And exit out to this interface, and who is the next hop. Just send the packet to the next hop. No knowledge about other links or networks on the domain. Okay, so these are the characteristics of distance vector routing protocol. EIGRP actually Cisco proprietary. That means you can run EIGRP on Cisco hardware. If you have two Cisco router, you can configure EIGRP. If you have one side Cisco, another side Huawei, you cannot configure EIGRP. Cisco added some feature from link state routing protocol to EIGRP, which make it far more than true distance vector routing protocol like RIP. Okay, so it is not a true distance vector protocol. Actually, we call it the hybrid routing protocol because EIGRP follows some rules from link state routing protocol also. Okay, that's why we can also say it is a hybrid routing protocol. Okay. EIGRP does not use broadcast. EIGRP never use broadcast to send the information to other neighbors. They will use multicast or unicast. Two EIGRP router. Okay. So they will send information one-to-one or using a multicast IP. Never broadcast. Suppose there is a switch. If we have multiple routers, they are all EIGRP domain. This is a switch, not router. We have 4 routers, R4. We have 4 routers. So EIGRP never sent information as a broadcast. Broadcast means one to all. It can be sent one to one, or it can be sent using a multicast address. EIGRP use a multicast address 224.0.0.10. Okay, they will send the multicast address. Okay, whoever joined the multicast IP, they will get the information. Okay, this is more effective. Multicast means group-based communication. Okay, multicast means group-based communication. and unicast means point-to-point communication. EIGR broadcast means one to all. If multicast, suppose these two guys only needs information. Okay, so these router then do what? It will multicast, group-based communication, not all. If they need one-to-one communication, they will communicate point-to-point. It is called unicast. Okay, so EIGRP doesn't use broadcast. It can be multicast or unicast.
Yeah.
IPv4, you can also use EIGRP to IPv6. Okay, EIGRP can be configured on IPv6. We are using currently IPv4. Okay, IPv4. I will show you the basic and also some labs on IPv6. Okay, later. Even some older network layers protocol. EIGRP also support older networking protocol like IPX, AppleTalk, but these are not used today, but also support. EIGRP support IPv4 and IPv6, both. Also IPX and AppleTalk, although these are not used today. EIGRP is 100% loop free. I will discuss why EIGRP is loop free. EIGRP has its own protocol number, which is 88, already discussed. Okay, so it is neither TCP, neither UDP. It works on network layer. EIGRP routers will start sending hello. This one is very important. Okay, I'll discuss now. It says, suppose you have two routers, R1, R2, two routers. Okay, now they want to, I will configure EIGRP, right?
Yeah.
EIGRP. So first they need to make the neighborship, right? Neighborship or friendship. Okay. So to make the neighborship, they will send hello packet to one another and also receive hello. Okay. Same thing as phone conversation. Suppose if I want to talk with you over phone, I will send hello, right? And if you also send hello, then we can continue. Otherwise not. Because if you never send me hello, I will never talk, right?
Yeah.
I will never talk. Same thing here. R1 wants to make a friendship or neighborship with R2. So first one is EIGRP will send and receive hello packet. If they never send hello packets and receive hello packets, they will never form the neighborship. Okay, this is task one. Then hello packet also used to maintain the neighborship. Okay, hello packet also used to maintain neighborship. So once you became friend, so if you never communicate with one another, then your friendship will be gone, right?
Yeah.
Same thing here. So they want to maintain the neighborship. How? Still they will use the hello packet to maintain the neighborship. That means continuous communication, right? They need continuous communication using the hello packet to maintain the neighborship. How? So, for example, R1 and R2 became neighborship. Now, this is the time to maintain the neighborship. How hello packet will help to maintain the neighborship? So, although they are become neighborship, R1 will send a hello packet, also R2. Okay, R1 will send a hello packet 5 seconds interval. 5 seconds interval. Okay, also R2. For example, R1 sends hello packet 5 seconds, after 5 seconds, R2 not respond. Again, R1 send hello packets after 5 seconds, R2 even not response. R1 again send hello packets after 5 seconds, so R2 also not response. Okay, so R1 will never send hello packets the whole time, right? Or continuously. It will send hello packets maximum 3 times. 5-second interval. 5-second interval maximum 3 times. So total 15 seconds, right? Total 50 seconds. After 15 seconds, R1 think my neighbor is down because I can get any response from R2. I have already 15 seconds passed, but no response from R2. Okay, so R1 think my neighbor is down. My neighbor is down. Okay, and break the neighborship. So this one is called the hold down time. Hold down time. And 5 seconds is called hello time or hello interval. Hello time. Got it? Using this way, they maintain the neighborship. Using the hello and hold down time. It will send hello after 5 seconds, every 5 seconds interval. And if they don't respond within the 15 seconds, they will think their link is down or something happened. Okay, so they will break the neighborship. This way they maintain the neighborship. Clear?
Clear. Yes.
Okay. So this is the line. EIGRP router starts sending hello packets to other routers just like WSPF does. If you send hello packets and you receive them, you will become neighborship. EIGRP uses a rich set of metrics. To find the best route, they will calculate the metric value using the bandwidth, delay, load, reliability, and another parameter MTU. These are the metric calculation value: bandwidth, delay, load, reliability, MTU. I will show you. So after which metric is lowest will be preferred. That means lowest metric value is preferable. Lowest metric value is preferable. Lowest metric value is preferable. Okay. Sophisticated metric that supports load balancing across unequal cost path. Okay, I will explain this one. Unequal cost path. So already in the first, the point unequal cost load balancing. So I will explain this one. So suppose this is your topology. Okay, this is your topology. R1, R2, R3, R4, R5. Okay, 3, 4, 2, 3, 4. We have multiple paths, right?
Yeah.
Going to the destination. If all the path costs are equal, suppose these one link 1, these one link 1, these one link 1, so what they do? They'll do the load balancing by default. That means packet will be sent on all the links. on all the links. Suppose one packet will go this way, another packet this one, another packet this one. If the path cost or metric value is equal, this is called equal path cost load balancing. Even any routing protocol like OSPF and EIGRP, if they have same link, same cost from source to destination, they will load balance. Load balance means every link is used to send the packet. Every link is used. Suppose 50% packet goes through this link, another 50% packet goes through this link. This is called load balancing. Okay. But this happens if they have equal cost path path cost. That means both the link cost should be same. Should be same. Then they will do load balancing by default. But what happens if the path cost is not similar? This link cost or metric value is 5. This link cost or metric value is 10. Okay. What happened? In this case, this is the best path, right? EIGRP will send packet only the best path only because the costs are not same. The costs are not same. But they also can do load balance on unequal cost. Unequal cost. In this scenario, EIGRP also can do load balance. Also can do. We need to configure. If we configure, EIGRP will do load balance on unequal path cost. I will show you lab in future. Okay. So just remember this point. Unequal cost unequal cost load balancing is happened by EIGRP only, but not by OSPF. Another routing protocol like OSPF cannot do load balance if the path cost is unequal. But if the path cost is equal, also EIGRP and OSPF can do load balance. Clear my point?
Yeah.
Okay. These are sophisticated metric that supports load balancing across unequal cost paths. Support for authentication, only MD5 authentication. Okay, support for authentication. Authentication means two router. They want to make a friendship or neighborship. Now, if I use authentication mechanism, for example, if I use a encrypted password, okay, for example, 1, 2, 3, this side is configured with MD5 or encrypted authentication type with a password, for example, 1, 2, 3, and on the other side, if we don't configure it, they will never become neighbor. Because both sides, we should have same authentication parameter. It enhances the security, right? It can be a hacker router. Okay.
Yeah.
Either this router can't configure the same authentication as this router, they will never neighborship. So we need to do the same authentication configuration on both sides.
Yeah.
It enhances the security, right?
Yeah.
Okay, I will do a lab on it. Manual summarization at an interface. What does it? Suppose this is R1, this is R2. They are become neighbor. The subnet is /30, for example. And if we have multiple network connected with R1, suppose 100 network, okay, 100 network. So the routing table will be bigger, right? Because we have advertised 100 network into the EIGRP routing protocol. So the routing table will be bigger. But we can minimize the routing table using the manual summarization. Manual summarization. Okay, on EIGRP, we can do the summary routes. We can do the summary routes. Okay, I have a lab on it. I will show you later. Okay, so then now instead of 100 routes, we can have maximum 5 routes. Okay, and routing table size will be lower. It will increase the CPU utilization. It will increase the CPU optimization, right?
Yeah.
Okay, and also it uses the lowest amount of RAM. If we have 100 routes, the CPU utilization will be high. RAM utilization will be high. But if we have now 5 routes only, then it will be low. Both will be low. Okay, and best perform. That's why sometimes we need to create the summarization of routes before advertise into EIGRP. I will show you in lab. Please be remember, uses EIGRP use only these multicast address 224.0.0.10. It is fixed. Okay, multicast address to sending and receiving hello packet. I will show you in lab to sending and receiving hello packet. EIGRP uses these multicast IP. EIGRP maximum hop count 255. What does it mean? Suppose this is your EIGRP domain. If you have 256 router, you cannot configure EIGRP because EIGRP supports only 255 routers maximum. If you have 255 routers maximum, you can configure EIGRP. But if you have more than 255, you cannot configure EIGRP. Okay. So this is the limitation of EIGRP. This is the limitation. Maximum hop count 255. This is the limitation. If you have 300 routers, then you cannot configure EIGRP. In that case, you need to configure OSPF.
Okay.
Okay. So this is another point. Neighbor discovery and maintenance using the periodic hello message. Already discussed, right? Neighbor discovery means neighbor establishment, and the neighbor maintenance already discussed. EIGRP has 3 tables. EIGRP maintains 3 tables. One is neighbor table. Neighbor table. Another is topology table. Another one is routing table. EIGRP maintains 3 tables. This is very important. Routing table. Okay, EIGRP maintains 3 tables. How? Okay. Suppose this is a topology. Topology. Okay, so this one is the source. This one is the destination. First one is neighbor table. Neighbor table holds only the neighbor table includes all neighbors information. Correct. So this router has, this is the neighbor and this is the neighbor, 2 neighbor. Okay. So these neighbor information will be on neighbor table. Neighbor table. Neighbor table holds only the neighbor information. So for this router, this is not the neighbor. For this router, this one is neighbor, this one is neighbor. For this router, this one is neighbor, this one is neighbor, right? So the in neighbor table, only the neighbor information, like interface number, okay, autonomous system number, interface IP. These information holds, these information found on neighbor table, but only neighbor, but only for neighbor. Okay. For example, we have an interface here. We have an interface here. We have interface IP. Also, when we configure EIGRP, we need to maintain the, we need to check the autonomous system number value, everything. Okay. So these router should have these router parameter. For example, interface number, interface IP, etc. Should have. Okay. So this will be on neighbor table. Every router, every EIGRP router has a neighbor table. On neighbor table, they have this information. Okay.
Yeah.
Then topology table. Topology table contains the full routes information, full routing information, routing info. How, for example, from this one, this is the source, this is the destination. We have two routes, right? We have two routes. This one link cost 2 and this link cost 5. Okay. So whatever the link cost, topology table, inside the topology table, we have the all routing information. These routes and these routes, these two routes will be found on topology table. All routes. All routes will be found in topology table. Again, routing table. But routing table, only the best route. Which route? This one. This one is the lowest cost metric. Only these best route will be in routing table. But topology table, all the routes from source to destination. All the routes from source to destination. Okay, this one, this one. These two routes will be on topology table and best routes will go on routing table. Okay. If best route is down, then second backup route will be immediately goes to the routing table. Second best route, which is on the topology table, will immediately goes to the routing table. And according to the routing table, packet will be sent. Got this point? Topology table holds all the routing table, and routing table holds only the best route. But if the best route down, then we have already routes in topology table, right? So
Yes.
the second one will then goes to the routing table because this one is the second best path. If you have another path which is cost 7, all the routes will be topology table. But this one is the second best path because this link is down, so it will goes to the routing table automatically. Okay.
Yeah.
Okay. Again, you can see we have multiple routes, right? So, for example, if any packet goes from here and then there, and also if come back using this router, also this router. So this is called loop, right? This will be loop. But routing table only the best route. There is a single arm communication, right? So as they have not redundant link, so there will be no loop. There will be no loop. That's why EIGRP is called 100% loop free. Because on routing table, only the base route will be installed. There is no chance to come again in the source. Because we have not used this link, we have only the base route in my routing table. Okay, and that's why there will be no loop. Again, using the which is called actually only called. Suppose if any packet goes to this router and if it sends back to this router again, if it sends back the route to the source again, it will be loop, right? It will be also loop. But due to the split horizon rules, it will never back to the source. Which route from here goes from here to here, it will never back to the source again. This is called split horizon rule. And due to the split horizon rules, the packet, which packet is sent from this one to this one, it will never back to the source. Okay, this is number one. Again, routing table holds only the best path only, not multiple path. If we have multiple path, there have the chance to become loop. Suppose look like that. Okay, in this way, if the packet goes here, then there, then there, okay, it will be loop. But if we have done this route, there will be no loop, right? So in the routing table, this is the route, not used both routes. Okay, so there will be this route is not in the routing table, only one path. So if we have only one path, there is no chance to make the loop. Also, due to the split horizon rules, if any packet goes from here to here, it will never back to the source again. Okay, so EIGRP is 100% loop free. Got my point?
Yes.
Okay. And this one is also very important. EIGRP neighborship condition. So they will become neighbor, right? But
Yes.
there are the rules. They must have mass some criteria. They should have mass some criteria or the neighborship condition. If they don't follow the rules or condition, they will never become neighbor. Suppose I want to make friendship with you. So we need to make some criteria, right? We need to match some criteria. Okay, if don't match, we will never be friend, right? Same thing here. This router wants to make neighborship with this one. So they must follow some condition. Either this condition never match, they can be never neighborship. First one is active hello packet. Both should send and receive hello packet. If they don't send and receive hello packet, they become never neighborship. So this is the first condition, active hello packets. Autonomous system number should match. Should match. Suppose if we use the autonomous system number on the left side 10, on the right side 20, these two are different, right? If they are different, not same, they will never become the neighbor. Okay, during the configuration, we will use the autonomous system number. Okay, if the autonomous system number never match, so they will never neighborship. So autonomous system number on both sides should be same. If this is 10, other side should be 10. Other side should be 10. K values. During the configuration by default, K values are identical. Identical. I will show you in lab what are the K values. If the K value is mismatch, not match, they will never neighborship. So these are the three primary conditions to become the EIGRP neighborship. Active hello packets, autonomous system number, match, and identical K values. Identical K values. If they doesn't match, EIGRP never make the neighborship. Another condition also should be matched. Both routers must in the same primary subnet. Suppose they will become the neighbor if they have common subnet, like this one. This interface should IP address from the same subnet. Okay? Otherwise, they will never become neighbor. Suppose if their interface have the IP address 2.2.2.1, if their interface 1.1.1.1, they will never neighborship because they have not identical subnet. So they should have, these two interfaces should have IP address from the same subnet. Otherwise, they will never become neighbors. Both routers already discussed. And authentication. Both routers should have same authentication parameter. Already discussed. Same authentication parameter. Otherwise, they will never become neighborship. Okay. The interface facing each other must not be passive. These interface can be made as a passive interface. Can be made. If you make these interface as passive, they will never send and receive hello. Never send and receive hello packet. If they don't send and receive hello packet, neighborship will be breakdown. Okay, so these interface and these interface never be passive interface. If you make it passive, then no hello message send and receive, and neighborship will be breakdown. Okay, I will show you lab on it. No worries. These interface should not be passive. So these are our neighborship condition. Very important. In interview, they ask this question. Actually, all the concepts are for very important for an interview. Okay, so I will show you the rest of the theoretical next class, but I will go for a simple lab now. Okay, so rest of the theory on another class or upcoming week. So I will do a simple lab on EIGRP now because we have done a lot of theory. Power on this. I will send you some video which will help you to solve this your EV engine issue. Okay, no worries. 1.4 is the IP. On 92.168.1. Admin EVE. On the same topology, I will configure EIGRP. Okay. This is our, for example, this is our EIGRP domain. EIGRP. I will whip out the previous configuration. Okay, now I will select all this device and start select it. Okay. Type no. Okay. Now we will do the configuration. So I will use the notepad. It will be easy to configure. First one is R1 router, right? Then enable config terminal, host name R1. Okay, interface first channel 0x0. This interface IP address 192.168.10.1 0. Okay, no shut. Exit. We have another interface, LAN interface. Interface fast Ethernet 1/0. IP address 192.168.20.1 0 and no short. Exit. Okay, this is the for router R1 and same thing for router R2. Change the host name and IP is 10.2 I will use, and on the left down side, LAN side 30.1. Okay, so this is your basic configuration. I will copy that R1. Done. R2. Done. Okay, now we'll configure EIGRP. The commands will be router EIGRP. This is the first command. And you need to write autonomous system number. Okay, if I go to the router and type router EIGRP and question mark, this is the range you can use for autonomous system number value. You can use any value. You can use any value from this range. Okay, for example, I will use the 10. I will use the 10. Okay, if I use 10 on the left side and 20 on the right side, what happened? Let's check. And I need to advertise the associate network or connected network. Suppose for this router, this network and this network is directly connected. Okay, so I need to advertise these two network into EIGRP. Is in the command. There are multiple ways to advertise network, but this is the easy way to advertise network. I will show all of this later. Network, simple, write the network. 10.0, another one, network 192.168.20.0. Okay, so this one and this one. I have advertised, should advertised all the network connected to the router. Which you want to, for example, this is my EIGRP domain. Okay, EIGRP domain. But if you have another domain on the left side, so for example, OSPF, and this interface belongs to OSPF domain, so this network should not advertised to the EIGRP, right? So I will show you later. As of now, this is your EIGRP domain only. So I will advertise all the routes connected to the network. Okay, I have advertised. Again, EIGRP by default advertise classful network. If we want classless, because we are using the classless right now, right? Not classful. Classful are never used. But if we want classless, what we advertised, the router will get as the same. Okay, so this is called classless, not classful. Classful means if you advertise, for example, 172.10.0/24. This is 172. By default, it is a classful network, right? Class B. But today we are not using the class B. We are using the CIDR value. What is the CIDR value? Classless interdomain routing. We are using the classless. But if you advertise this network, this router may got classful routes. For example, 172.168.20.1. 16.10.0/16. I have advertised 24, but this router can get /16 because this is classful in nature. And EIGRP will by default send or advertise the classful network. Classful network, but we don't want classful. That's why we need to put another command, no auto summary. Auto summary. To get the classless routing. To get the classless routing. Okay. So I should use the no auto summary. What I advertised, this router will get that. Okay, it will not follow. EIGRP then not follow the classful boundary. This is actually your classful boundary. What? Not 24, right? Classful boundary, it will be 16 because this is class B. Okay, but now we are not using the classful network. We are using the classless. Only the CADR value. Whatever the number, no problem. Okay, so if you want the same network on the neighbor, you need to apply the command no auto summary. I am telling the EIGRP, I am telling the router, you don't use you cannot use the classful network. You should use the classless. Okay, so to achieve this goal, I need to apply this command no auto summary. No auto summary. Okay, maybe here we have this. So this is for router R1. Okay. On the right side, I will do some wrong configuration. For example, on R2, I will use the 20 and let's verify what happened. And the network will be, this one will be 30, right? This is the LAN network 30, this one, and 10.0, this one. Okay. So I will copy this command. Router R1, no summary, done. On the right side, I will use this command. Router 2. Okay. And let's verify using the command show. We will show the neighbor table. Using the command show IP, EIGRP, neighbors. Using this command, we can verify the neighbor table. And we can also verify if my neighbor is found. If I can found my neighbor or neighborship is established or not. Using this command, we can verify. Enter, and it shows no neighbor. No neighbor. Because we have not used the same autonomous system number value. Okay, here we have used the 10, on the right side 20. Okay, now what we need to do? We need to remove the configuration. No router EIGRP 20. Now we'll correct this and put this configuration again. Done. And as soon as we have used the same autonomous system number, you can see we have found this message. Neighbor is found. New adjacency. Neighbor adjacency. Neighborship is built. NBR sense means neighborship established. And EIGRP autonomous system number. And for router R2, my neighbor is 10.1. This is my neighbor. 10.1 is on the right side IP, right?
Yeah.
Okay, so I can find the neighbor. And again, we can verify using the command. And show IP EIGRP neighbor. I can now show the neighbor table. Neighbor table. Okay, I am applying this command on this router 2. And my neighbor is this router. And IP address here is 10.1. You can see 10.1 is the neighbor IP. 0 is the first neighbor. Interface, on interface, first Ethernet 0i0. On which interface you have found the neighbor. On first Ethernet 0i0. Okay, this is the sequence number. Sequence number is automatically changed. by default. Hold time, uptime, how many seconds the neighborship is built. Round trip time, it is the this is the message sent from this router and reach to me. Round trip time. Okay, and hold second. So I need to found. Okay, what is hold second? I will tell you tomorrow next class what is hold time. Okay, so it is also incrementally value. Okay, let me check again. What is the value? Okay, so hold time. Hold time means okay, I have forgotten that. I will explain later. Okay. So uptime means how many? So already we have 2 minutes and 7 seconds. Okay, 2 minutes and 7 seconds. Our neighborship is happened. Okay. Now, suppose EIGRP will send hello message, right? Hello message. I will verify it. EIGRP sends hello message and send receive hello message. I will verify it. Okay. So I will use debug command, but never use debug command in your production network. Your full network will be collapsed or down. So router EIGRP debug. I will run some debug command. Debug EIGRP packet hello. Okay. Using this command, I will show you if the router is send and receive hello packet or not. Okay. Using the debug command. Debug EIGRP packet hello. Then enter. So debugging on, and I will get continuously message. Continuously, I will got message. If you don't stop the debugging command, then it will run. Okay, and your full of the network will be collapsed. Okay, so never run this command in production network. It is only for test purpose. Now I need to stop the debug. Undebug all. Is in the command undebug all. Okay, if you type undebug all, it will be stopped. Undebug all to stop the debugging command. Debugging means they are changing the multiple type of packets. Okay, internal packets. You can see on interface first is 1/0 sending hello, right? First is 0/0 sending hello. Received hello on first is 0/0. Sending hello on first is 1/0. You can see. Okay. So that means it probes EIGRP sends hello packet. Okay. Hello packet send and receive. Okay. We can verify. EIGRP send hello and hello packet and also receive hello packet. But only these two interface, because these are two router. So router send hello packet on that interface, also receive hello packet on that interface, because on the other side we have the router. Same for this one. This router also send hello packet to this router and also receive hello packet. But here is a PC. That's why router will send hello packet only. Send hello packet only. Never receive any packet from here, because on the other side, this is not my neighbor. This is actually my normal PC, not router. Okay. So this way they will only send hello, not receive hello. Okay. Now, if you apply the passive interface command on any of the interface, neighborship will be breakdown. Passive interface should be make these LAN faces interface. Why? Because other side is not a router. Other side can be switch and all our endpoints. Okay, they do not need the hello packet. They do not need the hello packet. So we can use the passive interface, or we can make these two interface as the passive. Got my point? Because they do not need the hello packet. Because if they send hello packet, the router CPU has to work, right?
Yeah.
Okay, so we will stop hello packets on the LAN interface, not on the interface. If you apply the passive interface on the interface, what happens? Let me check. Configure T, router EIGRP10, and passive interface, first Ethernet 0 by 0. 0 by 0. 0 by 0 is what? 0 by 0 is this one, right? This one.
Yeah.
If I apply passive interface, what happens? Neighborship will be breakdown. Let us verify. You can see neighbor is down. Neighbor is down, no neighbor at all. If we apply command to verify the neighbor table, show IP, EIGRP neighbor. No neighbor, right?
Yeah.
So this interface should never be passive. Now I will remove that command. Router EIGRP20, and I will copy this command and apply no before this command. Type no and paste it. And it will be up again. You can see
Yes.
new adjacency. Again, neighborship is built up, right? Neighborship is built up. New adjacency is up. Now I will make these interface only passive. Passive interface, fast Ethernet, 1 by 0. 1 by 0. Okay, passive interface, fast Ethernet, 1 by 0. Now no neighborship will be breakdown because this interface is not belongs to our neighborship condition, right? On the other side, we have no router.
Yeah.
Okay, so should make these interface, LAN interface or other interface which are not participating in neighborship condition or neighborship establishment, we can make that interface as a passive interface.
Yeah.
Okay, so same thing for router 2. Router EIGRP 10, passive interface, fast Ethernet 1 by 0. Okay, passive interface. Now, if we run the command, debug command again, now we can verify. Okay, again. I will run the debug command again. Debug EIGRP packets hello. Okay, we'll capture some packets. If on first, can you see first Ethernet 1 by 0 here? Let me check. No, right? No first Ethernet 1 by 0 here. Only first Ethernet 0 by 0 is used for send and receive packet. Can you see? Yeah. So that means 1 by 0 is passive interface. No hello packets will be sent on that packet. Okay. Now I will undebug all to stop the debug. Again, I will run another command, another debug command. Debug IP EIGRP neighbor. Okay, let me check another debug command. Nothing here. I will undebug all first. Undebug all. And another one, debug EIGRP packets, transit packets, packets. Previously, I have sent the hello. Hello. I will use the hello. Okay. Just right now I will use the debug EIGRP package hello. Previously, I have used the debug IP EIGRP neighbor. No, neighbor. No. Package hello already. Yeah, already used. I will use another one to show you something. EIGRP. What is the command? Neighbor. Okay, let me run this command. What happened? Not working. Okay, let's try undebug all. And try it with another command, debug all, undebug all. Okay, debug IP packet. Okay, these one maybe. IP packet, debug IP packet, detail. These one. Okay, got it. Debug IP packet detail. Okay, using the, I am show you something. Okay, let me stop the undebug all. Debug all. Okay, so let me show you something. You can see EIGRP use multicache address to send information. Can you see?
Yes.
This is the multicache address is used so to send their information, different parameters. Okay, source this one, first is 0 by 0, destination is this one. Destination, that means they always send the information to the specific multicache address only, which is 224.0.0.10. Okay.
Yeah.
And on port number 88, you can see EIGRP use the EIGRP works on network layer, and also they use the port number 88, IP
Yeah.
port number 88, right?
Yeah.
Okay. So this is very simple lab, but we have learned a lot of concept. So upcoming class, I will do the other labs, other theory. As of now, you have any question?